AV over IP, it's the hot topic in our whole industry. Everyone talks AV over IP. Everyone says, look at my AV over IP product. Mine's better, mine's worse. I guess nobody probably says theirs is worse. But it's all we're talking about in the press, in the meetings. And yet, when you look at the real figures, the real sales numbers, 80% of this market is still the matrix switch, right? So why is that? Why is AV over IP something we all want to talk about, and yet we're still buying and installing matrix switches? I think there's two reasons for that, Jason. I think one is that most AV over IP products make compromises that are not always acceptable, right? They use heavy compression, and that creates image artifacts, and it creates latency. There are times when those things are acceptable, but there's a lot of times when it's not. And the other factor holding us back, I think, is the lack of standardization so far. Everyone in this marketplace outside of SDVoE has built their own system for their own devices. You know, a Crestron works with a Crestron, and that's it. And on the one hand, that's how we, as an AV industry, have been functioning since the beginning of time, right? Nobody expects us to be interoperable. We live with that compromise. The challenge for AV over IP is that more and more this is a buying process controlled by the IT department. And the IT department is not at all accustomed to a world where they're stuck to one vendor now and forever, right? So you don't go to the IT guy and say, oh, okay, what kind of computers do you have? Oh, you have HPs? Well, then great, here's an HP printer. It's the only thing you can buy. That sounds ridiculous, doesn't it? And yet, that's exactly the conversation that we as AV sellers, marketers, installers have been having with those end users since the beginning. Well, the IT guys are not going to stand for that. They're going to demand interoperability, and that's where SDVoE comes in. So SDVoE is an interoperable standard for AV over IP. It's a complete ecosystem. We have 51 members who build products, including encoders, decoders, but also network switches, networking infrastructure, control software. Every single part and piece of the video distribution solution is represented by one or more of our 51 manufacturers, right? So then we're delivering AV over IP flexibility because that's our architecture, but because we leverage 10 gigabit Ethernet and we use the least compression possible, in fact, most of the time we use zero compression, we're actually able to deliver the same performance that your matrix switch gave you, right? So that's why we call SDVoE the matrix transformed. A little more about the Alliance itself. The Alliance is a nonprofit organization that's a consortium of members. I already told you there's 51. We're owned and operated by those members, and our only purpose is to drive standardization and to try and frankly push out HD-based and point-to-point technologies and replace them with Ethernet as the one and only way that our industry moves audio and video signals around. Where has SDVoE been installed? The answer is everywhere. We've seen installations in broadcast facilities, we've seen installations in the home, and then of course everywhere inside that broad market that is professional audio video, right? Corporate enterprise, house of worship, education, event spaces, rental and staging, and so on and so on. This technology fits literally anywhere that you've thought of using a matrix switch before. SDVoE can solve that application. And why? Because we're undergoing a massive shift in the core technology of AV. Right? If you think about it, since the very beginning of TV, we've used a matrix switch to connect inputs to outputs in the highest quality and lowest latency way possible. That goes all the way back to the beginning. You know, black and white TVs were hooked up and switched through the studio on a matrix switch. It took 80 years since then, 80 years, until finally the technology became sufficient that we could chop up those signals, turn them into packets, and move them across an AV network, right? And this is sort of where we've gotten to in the last 5 years. This is what's driven that conversation I talked about. Everyone's talking about AV over IP because we can replace that expensive proprietary Ethernet matrix switch with an Ethernet switch. But then SDVoE takes that one step further. By standardizing, we dramatically simplify the design architecture, right? If you really think through the hardware architecture of an SDVoE system, every single system is the same. It's an encoder at every source, it's a decoder at every display, and a 10 gigabit network in the middle. That's it. Maybe you've got 3 endpoints, maybe you have 3,000 endpoints, but at the end of the day, this architecture looks the same. So because we use 10 gig and deliver the performance of a matrix, that's why we say we deliver matrix switching, which is a function, it's a verb, without the matrix switch, which is a thing, which is that big, bulky hunk of metal that costs hundreds of thousands of dollars at the center of your rack. We don't need that anymore. That's not to say the matrix is all bad, right? It was with us for 80, 90 years for a lot of good reasons, right? And there's a lot that we can look at and learn from in that time, in the features that it evolved and the capabilities that it has. The first of those is performance matters. The reason we use the matrix switch is because it delivers video with the highest quality possible and with the lowest latency possible, right? So if we want to disrupt that market and replace the matrix switch, we have to deliver exactly the same performance, and that's what SDVoE does. In Pro AV, of course, the matrix switch has adapted to a lot of extra features that don't strictly have to do with moving video around, right? These are the control ports out on your receiver, you know, to have an RS-232 connection to the TV to turn it on and off. CEC, infrared, all of these control signals have been built into the high-end matrix switches to help extend that control network, right? Because honestly, who cares how good your video quality is if you can't turn the TV on? So SDVoE has taken that lesson, of course, and our endpoints incorporate all the same kinds of device controls that you would expect. The third lesson is that audio is just as important in an AV installation as video. This is something that even many matrix switches forget about, but the good ones have capabilities like full support for stereo and multi-channel, down mixing capabilities, and the ability to route audio independently from video. SDVoE shares all of those same capabilities, right? So far I've told you how SDVoE can match the matrix switch. And in fact, we've got a demo around the wall here after the talk you can go see for yourself. An SDVoE system running in parallel to a matrix switch system, and you'll see that from a raw performance perspective, there's no difference whatsoever. One advantage that the matrix switch has traditionally had over AV over IP is its modularity. Right, today when you guys think of a matrix switch in Pro AV, you're really thinking about a big empty box with some card slots that aren't filled yet, right? And that's because we recognize that designers need different complements of ins and outs for different jobs. So you buy a chassis and then you put some HDMI cards, some HD-based outs, some SDI cards, whatever mix and match you need. AV over IP before now has been disadvantaged by that because when you have local sources to the switch, maybe you've got a bank of PCs or a codec farm in the rack, or you've got cable TV boxes in the rack. With a matrix switch, you put in an HDMI card, you connect those sources right to the switch, and off you go. With traditional AV over IP, of course, that cable TV box has to plug into an AV over IP encoder, which then plugs into the switch. You've got an extra device, extra power supplies, extra stuff in the rack. So what's great about the SDVoE Alliance is that manufacturers in the group can work together. So here we have Netgear, who's worked with a couple of our different manufacturers, and those guys have put out a new card for Netgear's 4300 Ethernet switch, right? So now you take this 4300 series Ethernet switch and you populate it with some 10 gigabit inputs and outputs, copper and fiber, and you can populate it with HDMI ports. So now what you're doing in the rack is taking your cable TV box and literally plugging it straight into your Ethernet switch, eliminating those extra boxes and extra steps and extra cost inside the rack. So we've taken that advantage the matrix switch had away and adopted that. The last thing we can learn from the matrix switch is that matrix switch prices never go down. Right? Every couple of years we say, oh, we got to go from 2K to 4K, then 4K to 4K 60, and now here comes 8K. And every year we got a whole new set of cards you have to buy. And by the way, these are $300 more than the last ones. And that's fine. Look, it costs a lot of money to develop these new cards. And in the big picture of the scale of IT, even the biggest AV manufacturers are quite small. And they have to recoup those investments. So they have to drive up prices. Here's an example I've given of a few different switch configurations. At the top of the list, they're an 8x8. So I'm talking about, in this case, a Crestron DM 8x8 loaded up with HD-based T ins and outs versus a Netgear M4300 16-port switch. And you see the cost difference. It's $18,000 list price versus $1,300, right? This is a 92% savings. Even all the way up at the high end, if I take a DM switch and kit it out with 72 ins and 72 outs, that's a $200,000 matrix switch. I can build the same thing out of 3 Netgear switches, fully non-blocking, for under $40,000. The cost savings here can be truly incredible. And over the long term, Ethernet prices go down while matrix switch prices go up. But we don't just match the matrix switch. We can also do things with SDVoE that the matrix switch cannot do. That includes our fast switching capability. Right? A matrix switch at its core has to change the timing from one source's timing to a different source's timing, and that interrupts the signal to the display. Now, this causes the display to resync. It takes time to switch. There are tricks you can do with a matrix switch. You can put a scaler at the end, you can do some frame rate conversion, and you can get that switching to look pretty good. And in fact, in the demo you'll see over here, we've got what I think is the best matrix switch out there, and you'll see its switching time is reasonable. It's maybe a third of a second. They've got a nice looking freeze frame effect that sort of psychologically makes it feel faster. And yet when you put it side by side with SDVoE, that's truly instantly switching. The moment you hit the button, there's a new image on the screen rolling. You see that SDVoE really outclasses the matrix switch in that environment. SDVoE can also create video walls. This is where we take a single image, stretch it across multiple displays. Here and in our demo, we're just using 4 displays, but of course this can scale all the way up to 64 displays if you need something that large. Here again, we can do fast switching, even on a video wall. And then SDVoE also has a mode that no matrix switch could match, where we genlock each of the displays back to the source, which means that those displays are all locked to one another. Now this solves a major problem for low-end video walls. You've probably seen this effect before when there's high motion content and there's a shape that stretches across multiple displays and it's moving. What you see when one display is a full frame ahead of another is you see tearing, and straight diagonal lines become broken diagonal lines because this TV is ahead of this TV, for example. It can be very distracting. It's especially bad if you're watching hockey, I find, because if you think about hockey from a video signal perspective, the center ice camera is pointed at this big white field with parallel red and blue lines that look like diagonal lines from his perspective, and that camera pans back and forth. So you've got these blue and red perfect diagonal lines just moving back and forth across the bezel, and you see the tearing, and it's very distracting once you notice it, and I'm sorry if I've just ruined your favorite sports bar for you. But SDVoE doesn't have that problem because we can synchronize those displays. Finally, SDVoE can do, we'll call it the opposite of video wall. We call this MultiView compositing. This is taking multiple images and putting them together on a single display. Right? So you know the applications for this. I can have picture-in-picture. This is my doorbell camera. This is monitoring 9 security cameras at one time, side-by-side collaboration in a conference room. There's a lot of uses for this kind of multi-viewer. In the matrix switch world, of course, it's possible to achieve this, but it means putting a dedicated and expensive windowing processor at every single display where you'd like to have this capability. Right? It's doable, but that's at least a $4,000 or $5,000 commitment per display. So as a designer, you have to very carefully think, if I've got 100 TVs, do I really want multi-view on all 100? That's another $500,000 worth of processing. Maybe I only need it, on these subset of rooms, and it's one more design problem that you have to think through. With SDVoE, this capability is built into the endpoints and controllable by software. So every single display in your network can become a multi-viewer by simply reprogramming it and telling it, I want these 3 sources to show up on the screen. It's done. One thing that SDVoE has and offers that not only the matrix switch can't, but neither does any other AV over IP solution that actually exists, is interoperability. Right? We've heard marketing messages now from the Ames Alliance and those guys that say they've got an open standard and SMPTE is going to be here and it's going to be great. Meanwhile, where are the products? Right? It's great that we've all sat around and written down a nice specification about how life should be. And maybe one day they'll finalize that, and maybe one day somebody will build a product. Meanwhile, SDVoE already has over 200 shipping products that you can find in our online catalog, and every single one of those products is compatible with each other. How do we ensure that? Because SDVoE has defined the behavior of the system all the way up to our API layer. That's all the way at the top of the OSI stack, the application space. API is an application programming interface. What that means is it's simply a set of standardized commands that tell the SDVoE devices what to do. There's a command that says route input A to output B. There's a command that says I want to scale this output to 1080p 60. There's a command for make a multi-view wall with 2 images side by side, and so on and so on and so on. This is how these systems are defined, software-defined video over Ethernet. And this is how we ensure interoperability. Because not only do they speak the same language and send the same AV signals to one another, but they all respond in the same way to the same control layer. So interoperability is guaranteed all the way down. Right? This is where HD-based-T interoperability sort of fell apart. How many of you have tried HD-based-T interoperability? And how many of you have had a successful, happy time with HD-based-T interoperability? Right. And it's not that they did something wrong. AV usually works. It's that, you find out when you try it, oh, well, the COM port doesn't work this way, or the power's incompatible. Whereas with SDVoE, we've defined everything about control and about how audio and video move, so interoperability is guaranteed by design. I mentioned the 200 products. Just last week, we launched on our website a new catalog of all of the SDVoE member products. So you can go to sdvoe.org/products, and you'll see this catalog. You can sort, you can filter, you can find the devices that are interesting for you. And keep in mind that all of these manufacturer products are compatible with one another. We use that API layer to our advantage, right? Because that decouples the hardware from the software and gives us a middleware layer that we can write to. So we get the question all the time, hey, I like SDVoE, can I use it with my Crestron control system? Well, the answer has always been yes, but previously you might have to create your own driver built on top of that API. It's an extra challenge. So we've taken that challenge away by commissioning and building our own SDVoE driver for those control systems. So now you can go to our SDVoE Academy at our website, sdvoe.org, and when you become a certified design partner, you have access to this to download for free and use in your control systems. So how does this all benefit you guys? As I see the Pro AV landscape, I see really three core components of our audience. Those are the installers, the system designers, and the end users. And there's a unique set of benefits that SDVoE has for each of those. For installers, the real benefit is simplicity, right? Those of you who've installed HD-based-T have tried to read the secret decoder ring that explains what length of cable you're allowed to use depending on what kind of cable it is, depending on what format you're using, what frame rate it is, whether you've got the DSC compression on or enabled or not. It becomes very complicated. And the answer might be 30 meters, the answer might be 150 meters. You need to go read the spreadsheet and try to figure it out. Right, SDVoE, we didn't try to invent our own physical layer the way HD-based-T did. We said Ethernet and 10G-based-T, all developed by IEEE, like those guys are smarter than us. Let's just use that. So our specs are the IEEE specs. 10G-based-T will run 100 meters on Cat6a cable. That's it. Doesn't matter what format, doesn't matter if it's 4K 60 or 480i, it's 100 meters all the time. The interoperability gives your users, installers, the confidence that things are going to work well, right? It's kind of a simple thing to think about, but if you're installing a system entirely of Christie endpoints, let's say, but there's one ZV device that you really like that you want to put in there, you can do that. But meanwhile, you're thinking, well, if the ZVs work with the Christies, work with the DVI gears, work with the Lightwares, then at least my system of all Christie devices is probably really going to work. So it just gives that extra confidence. And the software tools that each of these manufacturers build are there to control the devices and manage them. So commissioning can become much easier. You can really automate the commissioning process and not have to go in and touch and manipulate every single device in a detailed and time-consuming way. For designers, the benefits are really about flexibility, right? Interoperability means that you're never limited to one manufacturer's catalog, right? I kind of touched on it a moment ago. Let's say you've got an all ZV system, but you really like Aurora's 2-gang wall plate for SDVoE. Well, you can build everything SDVoE, everything ZV in that example, and then still take the Aurora faceplate that you like and put that in your system with confidence that that's going to work. So you get the entire breadth of the SDVoE catalog to design from and never just one manufacturer, right? The simplified hardware architecture speeds up the design process. Like I said, it's encoder on a display, encoder on a source, decoder on a display, network in the middle. Now you can spend the rest of your design time focusing on other elements of user experience rather than on the nuts and bolts of, where exactly do I want my multi-viewers, what ports of the matrix switch am I going to use for the multi-viewers, what am I going to use for the displays, and so on and so on. It takes a lot of the time out of the design process. For end users, it's really about cost savings and confidence, right? The confidence that they're never going to get screwed over by a system that has image artifacts, that has latency, right? Because there's always that nervousness when you switch to a new kind of technology from something you're accustomed to, right? And everybody knows that if the system is going to have an artifact problem, or if it's going to have a latency problem, it's only going to show up during the CEO's all hands, right? It's never going to show up while you're commissioning or while the day-to-day operations are happening. It's always the worst possible time. So SDVoE gives those end users the confidence that the performance and the capabilities that you've been accustomed to for all these years are available on this system too. And there are a lot of ways that SDVoE, besides being often cheaper to buy, is much lower cost to operate, right? And there's a few reasons for that. That's the software flexibility I've touched on is a big key, right? How often does it happen that you go to a job, you install it to the user specifications, and within 6 months they're calling up and saying, you know what, this is great, but I wish it also did this, or I wish it did something a little bit differently, right? And your answer today in the hardware world is, well, okay, we can do that, but I have to redesign part of the system. We might have to take some gear out and throw it away. We might have to buy some new gear. And I think very often what happens is the user says, maybe sometimes they say, okay, let's do it. Maybe too often they say, you know what, that's too expensive. My budget's already gone. No thanks. And then what happens is maybe even worse. The system starts to fall into disuse because it no longer meets their needs. With SDVoE, it's a much simpler thing. The hardware's already in place. If you need to expand it, more inputs or outputs, you just put down more encoders or decoders. But even if you need to change the system's function, that now becomes a programming issue, right? Somebody says, you know, I really wish I had a multi-viewer in this conference room. I want to do side-by-side PowerPoints. Well, then that's just a matter of send your programmer in and make a new software mode for the system. So the cost is only the cost of a little change to the programming, right? Convergence of infrastructure is a big savings too, right? Today in a traditional world, they'll have an IT network to think about, manage, and they'll have an HD-based T network to think about and manage. As we move into a world of converged networks, soon we'll be able to say there's just one IT infrastructure that's capable of managing all of the IT traffic and all of the AV traffic. And now we've reduced the number of systems that have to be maintained and have to be managed. So these are just some of the ways that the end user benefits from a lower overall cost of operation. There's really no rocket science to my predictions here about where the industry is headed, right? All technology, communications industries go through exactly the same pattern. And we're just into the phase, moving into the last phase for us, right? The first phase is always analog systems. I draw the analogy to the telephone network because that's easy, right? Analog telephone networks, that's people with very small fingers taking patch cords and plugging them in. They plug one in that goes to Rob's house and they plug one in that goes to my house, and now we can talk on the phone, right? In AV land, of course, that was the days of VGA, of component video, of everything before that. That was analog. Then the systems transition from analog to digital, right? In the phone network, those were PBX, matrix switches. In our AV land, that's HD-based T. Those are digitized signals moving over a matrix switch. Eventually, the electronics become sophisticated enough that we can packetize that data and move it over an IP or an Ethernet network, right? So 20 years ago, the phone system did this, 20, 30 years ago, as it moved to voice over IP. Today, we're deep into that phase in AV, right? Where everyone has some sort of AV over IP product line. These are our IP phase products. But there's a final phase that we're just on the edge of, and we haven't gotten to yet in AV. And that's the phase where we focus less and less on products and technology, and the focus becomes much more on software and user experience, right? So think about the phone example again. Now today, if you go out and buy a new cell phone, I already know what is the first question that you're going to think about and answer, right? And that question is, do you want an iPhone or do you want an Android? That question is about user experience and about software. It's about which platform do I enjoy, which platform has the applications that I need, and that's the first choice you're going to make. Once you've decided on an iPhone, then you decide, do you want an iPhone 8 or an iPhone XR? Do you want whatever the Android phones are? I don't know. But the point is, what you're not thinking about is, do I want a phone with UTMA 1900 megahertz or TMDS at 850? Because nobody cares, right? What I care about is what's the application, what's the experience it brings me, right? And so that's where our next step is for AV. And SDVoE is built to be that platform, to be that iOS for the AV industry, right? A standardized, interoperable platform that allows us to use software to focus on user experience and not worry about how the hardware works as much underneath. So that's why we say SDVoE is the matrix transformed. Thanks everybody, and I hope you enjoy the rest of your day.